Hi, this is Matt Espe. I'm Mavanwi's co-instructor for this course, and today I'm going to be leading us through a bit of review and a bit of new material on how to work and manipulate data frames. Right off the bat, you're going to notice that my setup is a little bit different from Vaughn's. I use a program called Emacs. It's functionally the same as RStudio. So if you look on the left side, you'll see I have an open script. I already have some stuff written there. There's some blank spots we'll be filling in as we go along. Over on the right is an open R session. And so it's just an R console, similar to what you've seen before. So hopefully you aren't too disoriented. So to start off with, I'm going to be creating a data frame that we'll be playing around with. I'm going to call this data frame X. I use the equal sign for assignment. It's the exact same as the arrow assignment operator. So this data frame is going to have two columns. One is named A, and it has the integers 1 through 5. And then the second column will be named B. It's going to have the month names for the first 5 months. And then I'm assigning row names, which are just the letters. If you're not familiar with this, R has a bunch of built-in constants that you can use, including month names. So if you look at, gives you the month name. It's also got the month abbreviation. And then the letters are the lowercase letters, and if you type it in all caps, you get the uppercase letters. So just some convenient built-in constants for us to use. So I'm going to go ahead and assign this X to the data frame, and we'll go ahead and look at it. And as you see, we've got letters as the row names, integers for A, months for B. So we're going to go over, there's a couple different ways that we can subset this data frame. We've seen a couple of them thus far. The simplest for data frames is going to be the $sign. So the $sign operator subsets by name. So if you do $A, it's going to give us the A column. And similarly, if we do $B, it'll give us the B column. However, we can also subset by these square bracket operators. These work with data frames, they work as row first and then column. And if you leave one value blank, that means give me all of that. And then, so this right here where I've left both the row and the column empty, it'll give me the entire data frame. If I say put a 1 here, it'll say give me the first row and all the columns. So we're with the square bracket operators, they can subset either by index, by a logical vector, or by name. And so this gets a little bit confusing, but hopefully we'll make it make sense. So there's a reason why I put row names on this. If we want the row name A, I put A in the row column, or in the row position, and we end up with that first row. If I want multiple rows, I can do the same thing with the vector. And so that gives us the A and B rows. I can also do this with columns. So actually I'm going to copy these down. And I'm just going to move this comma. So instead of leaving the column space blank, I'm going to leave the row space blank. And so this is similar to the above, but now I'm saying give me all of the rows and then give me the A column. We'll run that and we can see we get the A column for all 5 rows. And similarly, this says give me all the rows and the A and B columns. A little silly because we only have the A and B columns. But you'll see how this all gets put together later. So, and then Von reviewed how you can subset with logicals. So this is one way to do data frames. There's one other operator that we'll talk about, and that's the double square brackets. So the double square brackets will extract a column. It is a little bit different than using the comma, but we'll probably review how it's different a little bit later. Immediately, you probably should never, you won't really want to use the double square brackets. I just put it out here so that you know. So if I do x double square bracket a, it gives me that a column. And this is related to lists because the double square data frames are a list. The double square bracket pulls out a subsection of a list. In this case, the subsection is the column. Again, we'll go into more detail probably later. But for now, you should just know that those double square brackets, you can use them to subset a data frame. So hopefully we're good thus far. One thing that's not intuitive to most people beginning R is that you can actually use indices to reduce a data set, which is what we did above, pulling out one row, a couple rows. You can actually use indices to expand a data frame as well. So in R, indexing, specifically indexing using the single square brackets, can take more indices than there are rows in the data frame, and similarly with columns. So if I do x 1, 2, 3, 4, 5, so that's all of our rows, and then I do 1 again, R actually returned that first row again. And you can actually do the same trick with the columns. So you can say x, give me the A column, the B column, and then the A column again. And you can see that it repeated the A column again. You might be thinking, well, this is crazy. Why would I ever want to do this? It actually ends up being really helpful if you want to, say, permutate a data set. So for example, let's say I've got these 5 rows and I actually want to repeat them a random number of times. Say I'm randomizing an experiment or something. So what I can actually do is I can say I'm going to use a variable I, and there's a function in R called sample. So what sample does is you first give it a set to sample from. So in this case, I'm going to give it 1 through 5. Say you're going to sample from 1 through 5. I want to have 20 values out. So this is the size argument, 20. And then I have to say replace equals true. If I don't say replace equals true, it'll sample 1 through 5, and then it won't have anything to give for the other 15 values. It'll give me an error. Let's say there aren't enough values to take 20 unique values. If you say replace equals true, it'll replace, after it pulls out, say, F2, it'll replace it. So here, we'll run this, and we can look at I. And you see, I ended up being an integer vector. And if we do table of I, you can see that each value has a random number. So, there's 3 1s, there's 8 2s, etc. So what happens if I use this I to subset my data frame? Remember I's length 20? Our data frame has 5 rows. If I subset by that, you'll see I end up with a data frame that is 20 values, has 20 rows, and rows have been repeated. So we actually end up using this quite a bit when we're doing this kind of like randomization. It also is really helpful when you have 2 data sets. Let's say you've got a data set for site characteristics, and then you have a data set for like observations, and each site only has one set of characteristics, but the observations, you have multiple observations per site. You can cast basically the site to those observations using this trick. So yeah, it's really helpful. It throws people off because if you accidentally give an index that's too long, you'll end up repeating your data set. So there's one other thing I need to mention is the 0 index. So what happens if we put 0 in here? So X, give me the 0th row. What it does is it returns an empty data frame. So if you look here, it's got the column names A and B, and then it says 0 rows. This might seem really dumb to you. Why would we want a 0? This actually is really helpful for when you are you're indexing into a data frame and you want to exclude something. So you want to, well, where we use it a lot is match, and it's a little bit. I'm going to leave that to a different lesson because match is like a whole different can of worms that every time you use it, you have to think about what you're doing. But you should be aware that if you index by a 0, you end up with an empty thing. And that can be really confusing. So the other thing you need to be aware of is you can actually remove certain things. So up till now, we've been indexing using kind of what we call positive indices. So we're saying, like, for example, this line of code, we're saying I want the first, the second, and the third row, etc. What if you want everything except for that first row? You can actually use a negative number to exclude that row. So here I say X minus 1. That says exclude the first row, but give me everything else. And you see we get everything but the first row. And this actually works with columns as well. So you can say -2, give me X but minus the second column. And it just gives you the first column. So thus far we can subset a data frame multiple different ways using a $sign. We can use a single square bracket. We can use names. We can use an integer. And then Vaughn covered using a logical index. One thing we haven't really covered is how do you create a new column? So here, let's say I want to add a column to X, which is, we're going to name C to stick with our convention thus far. And we want, I don't know, what do we want to put in here? Let's put in random values. So our norm is a function that gives you a random values, and I say I want 5 random values. By default, it's like mean 0 and standard deviation 1. So we just created X $C. So the same operators that let you subset, they let you create a new column. So here I'm saying $C, that's a column that didn't exist before. I use the assignment operator and I say fill it with 5 random values. So if we look at X, now you see we have a new C column. So what happens if I say X $, I'll do it over here, X $D. So D doesn't exist yet, right? When I do that, it says, well, this is null. Well, what if I want to fill X $D with the uppercase letters, 1 through 5? See, I just assigned into D, and now when we look at X, we've assigned that. So we'll be using this oftentimes. For example, let's say you want to separate out a date time, so you have a date column and a time column. You need to create new columns, and so you'll use this $sign operator. You can also use the square bracket operator So if I say xd equals letters, this also works. That there's one other way that we can create columns. And well, there's a couple different ways. In R, if you haven't gotten this already, there's any given operation, there's probably 3 or 4 different ways to do it. It's not there to confuse you. It's just there's certain situations where one is better than the other. But so the other way that you might see creating columns is a function called cbind. The C stands for column, and the bind means bind together. So here I can say x, and then d equals, actually let's do e equals 5 through 10. There's one difference here. Oops. If I can get my math right. There's one difference here. Notice that there's no assignment here. So if I did cbind of x and then I did e equals that, if I look at x, I have not changed it. So when you use cbind to add a column, you want to assign back into it. So I would do x equals, and now that column is there. Okay, so we've covered using the subsetting rule to not only subset out data, but also increase repeat columns, repeat rows, and then we've created columns. This is all a little bit elementary, and it's not very interesting to do with a toy data set. So we're going to go back to the cod parasite data set, which we used in the last lesson. If you remember, it looks like this. Oops, that's not very helpful. Let's look at the structure. So it's a data frame. It's got 1,254 observations, got 11 columns. We've got sample intensity, etc. So there's 2 things that we might want to do. One, it's not clear what order this data set is in. So we might want it in a certain order. For example, just based on the structure, we see that the sample, it looks like it's ordered by sample number. It's not clear that it's sorted by year. So how would we reorder this data set? Well, so in office hours, we covered a function called sort. And sort basically just takes, so let's say we're going to do y equals our norm, our random number generator, and I'm going to do 10 values. So we look at y. We've got a mix of positive and negative numbers. So I can use sort, and it'll actually sort that vector. By default, it's in increasing order. You can actually change that. Decreasing equals false. Oops, that's the default. Decreasing equals true. So sort is how you sort a vector. And we can actually do this with one of the vectors in our data set. So if we wanted to look at, say, sorting the weight, and do sort cod, and it'll give us all the weights sorted in increasing order. However, there's one thing that you should note. When we do sort, we haven't actually changed the data itself. This is a principle of R where R basically wants no side effects. So it will not change the order of how your data is arranged unless you actually do that. So if we look at cod, or here we'll do cod. If we look at the weights, we can see they aren't changed. All we did is we changed the order that they're sorted in when we printed it to the console. So it's a little counterintuitive. If you're used to Excel, when you do like a filter or a sort, it actually changes the order of the data. Here we need to do two things to actually change the order of the data. First, we're going to use a function called order. So order is like sort, except instead of returning the values in sorted order, it's going to return the indices of the sorted order. So what does that mean? I'll look at the head of this. So this is going to say, we're over here in the console. So this says the first value of cod, the weight column, belongs in the 365th place in order. So if we put them in order, that one goes in 365. Well, we know from before that when we index by something like this, it'll actually change the order. And so what we can do is, if we do cod of I, so we're putting the columns in that order, and for simplicity, I'm going to do just the weight column. You can see that we actually got the weight column in order, but I can also do the entire data frame. And so this sorted the entire data frame by that weight column. So again, the principle of R is that there's no side effects. So if we actually look at the actual data frame, hasn't changed. You can see that the weights are they're not in the order of the weight column. So again, if you actually want to reassign this in this order, you do need to reassign. So we're going to call it cod2. And we'd say cod I, comma. So we say, take the cod data set, take this index, which puts it in order of the weight column, and just rearrange it. And now if we look at the head of cod2, we can see it's in a different order. Hopefully that's clear. So there's one other operation that we want to do here. That is, and this actually came up in office hours, this data has NA values. It has NA values in the intensity column. So how do we find these NA values? Well, I'm going to use an index J, and we use a function called is.na of, let's say, cod intensity. So what is J? J is this logical vector, and anywhere where the value in intensity is an NA value, it's a true, otherwise it's false. We actually do a table of this, and it tells us that we have 57 NA values in that intensity column. So what if we want to pull just those rows where intensity is NA, and we want to look at them separate? So we can actually use this, logical vector to do the subset. So I'm going to create a new data set, cod NAs, and it's just cod of comma J. And here, remember, this index is going to say anywhere where J is true, extract that row. And we can look at this and confirm that it's all the NA values. So we've just done a subset of these NA values. What if we want the non-NAs? What are we going to call this? Non-NA. It's getting a little silly. So we can do cod, and remember the logical operator, the exclamation point means not. So if we do cod not J, this says give me all the rows where the J is not true. And if we do cod NA, we can see that we extracted all of those values. So, and just to confirm, let's look at the structure of that. And you can see we have 1,197 observations. So we've gotten rid of those NA values. So let's say we want to save both. We want to go back and look at the NA values and see why they're NA. And we also want to save the non-NA values for our analysis. So how we can save this is we can use a function called write CSV. So this function, there's a whole bunch of write dot something, write CSV, write tab separated, write table. The first argument that it takes is the R object to write. And the second thing it takes is the file path. So we're going to say the file is, we're going to call it cod NA values. If I can spell. And here I can look at that. I saved it just in the base directory. And there is our CSV with our NA values. And similarly, we can do this with our non-NAs, with our DUM file name, or DUM object name. We haven't come up with a DUM file name yet. We'll call it complete values. And similarly, we can pull that up. And there's our data frame. So hopefully this was helpful. If you have any questions, feel free to reach out. I know it was a little quick. And yeah, hope it's helpful.